Good morning everyone. So in the last tutorial we have finished our tank model practice using the most fundamental command including trim, split, boolean, all these kind of basic command. And now we are going to finish the nerves modeling tutorial before the midterm. So let's take a look. First part is about project. Project is a command which allows us to project some kind of patterns on the surface of the geometry. And it's very easy to do that, also very useful to use. Let's take a look. First thing is, hold on your Shift key to select the operation frame, and hold on your Auto key, move them to the left side, and let's start with this one. And you can draw any kind of pattern you want. Let's go to polygon and draw multiple curves. Press enter, you can repeat. And for sure you can also draw another one including circle. Okay, so probably this one will be my pattern which I want to project on the geometries. And second, you need to draw a geometry for projected. So for example, if I want to project all this pattern on a box, I will click here and draw a box. Probably it's too small, so let's draw that again. Okay, once you finish your box drawing, let's copy these two things to the third Y operation frame. And the reason why I do that is just hope you guys can see the step-by-step operations. Hold on my Auto key, put the box to the third wireframe, select all this pattern, and hold on the Auto key, move them to the third box. I will move them up, and you can choose any position you want to project. For example, if you want to project in this direction or in this section, but make sure there are some intersections with the box in the perspective. So for example, let's do this. Let's do the project in this way. Let's type in project, P-R-O-J-E-C-T, and select the points or the curves which I want to project. And then press enter. Then select the surface which I want to project onto, so which means the box. And then finally press enter. And right now, based on the position which you choose to project the object on the target object. So as far as you can see, because we choose in these weird perspective positions, so some part was distorted, some part was stretched and extend. And let's do that again. Let's copy this one to the fourth operation frame, and let's copy this one to the top view. And if you project in this way, or we go to the top view to project, let's go to here. Move this one down, and type in project. Select the curve first. Don't select the box, so I will use Control and to deselect the box. Okay, and press enter. And then select the box. Once you finish, press enter. And if we go back to perspective, you can see right now the scenes was directly on the top view. And it's different from this way because in this part, the position is a little bit different. We're using probably something like this or this to project. So the final result is a little bit different. So based on the position you choose, we can project the object in different directions. And also, once you have this pattern on geometry, we can use in trims or split to cut off this box. For example, let's use in trim. Select all the patterns on the box, not the box itself, but the patterns. Press enter. And now we can start to cut. You can cut certain area you want. And through this way, actually, we can create some kind of weird or avant-garde architecture for shower pattern. So that's the function of project. And for sure, when we are working on CAD model, we can also project the facade or side view to the geometries so that it could be a reference for us. So we can use in project in many different ways. Now let's go to the second operation frame. So the second part is about flow along surface. If you remember, last time I have teach you guys about how to using flow along curve. And this time we are going to using flow along surface. And the first one, flow along curve, is to make the object flow along one linear curve. And now we can make the object flow along a 2D surface, or maybe a freeform or a non-planar surface. So let's take a look. First things, we need to create a basic frame, basic surface. So let's go to here and choose a rectangular plane, and it will be easier for us to operate. So this is the basic frame, basic surface. And we can do rebuild so that we can have more control point to operate. And once you finish, press enter. And I will copy this one to second operation frame. And you can turn on F10 or go to here to turn on the control points. So let's start to do the operation. It's just a manual operation, so you can do anything you want. You can just make them become something like this, weird geometry shape, some freeform. Okay, so once you finish, press F11 or go to here. Use your right mouse button to select this one to turn off the control point. So now we need to choose the object we want to flow. So probably this part I'm using cones, and you can do anything you want. For example, like I just drew a box right here, and maybe copy more. Hold on your Auto key, and you can do the copy. But for now, it's not they don't have the same distance between each other. But I think that's fine because it's just a practice. But you can do any pattern you want. So if you want to rotate or something, it's up to you. Okay, so now we have the object, basically, which means this kind of a box unit. That's the thing you want to flow on the surface. And here is the basic one, the basic surface. And this is the target surface. If you remember flow along surface, flow along curve, also we need one curve, and another one is target curve, and things on the base curve, so that we can flow the base object to the target curve. So this is the same logic. So now we have the base plane, target plane, and the object for flow. So let's start to do flow along surface. Let's type in flow along surface, the second one, or you can find right here, flow along surface. So just follow the hint of Rhinoceros. Select the object to flow along a surface. So basically it means all these units. Let's select them. And don't select the wrong things. Hold on Control key to deselect the wrong object. Once you finish your selection, press enter. And choose the base plane and choose the target plane. It's better to be the same position. Like if you choose in the corner points of the base plane, it's better for you to choose the same corner points of the target surface. It will take some time. So now, as far as you can see, it becomes super weird. Why is that? Because Rhino will help us to transform the cube in order to follow the curvatures of the target surface. So it becomes something like this. I will copy this one so that you can take this one as a reference. And also I want to turn off the ISO curve on the surface. So it becomes super weird. Everything change and distort. So if you don't want to see this one, I will delete the target object, but I will leave the surface. Let's do that again. Let's do the flow along surface again. Type in flow along surface. Choosing the target the object we want to flow, which means the box. Press enter. Choose the base plane and choosing the target plane. But before we do that, we can do some change. For example, like the rigid, we can choose rigid equals yes and press enter. Sorry for that, but we have to do that again. Select object, press enter, base plane, rigid, and select the target. Okay, so for now, as far as you can see, once you choose rigid, which means all these box, all these units, they will not be distorted by the curvature of the target surface, so you can keep the same unit. But usually when we are working on this kind of stuff, well, we will, for sure this one is an example in order to make sure you can see the functions of flow along surface. So we make a super weird and super free-form surface. But usually when we are working on a real model, like a helmet, or maybe like your Nike sports shoes, we are going to flow a pattern on that one. The curvature will not transition, has this kind of severe transitions. So actually we don't have to choose rigid. We can just choose a rigid equals no and make the object flow along the surface, and also follow the curvature of the surface itself. So you can get the things you want. Alright, so that's about the flow along surface. Okay, so now let's take a look of rebuild surface and using control point to sculpting the geometries. And in the next part of the semester, so basically after the midterm, we'll start to teach you guys something more about subdivision surface. And we can using subdivisions to model in some more detailed and organic model, just like what we are doing inside 3ds Max or Blender. But inside Rhinosys, I think it's much more precise compared to 3ds Max. It's very similar to Maya, but not that intuitive, but very precise. And so for this part, I think it's just kind of like a preview and make you to try using control surface, control point to model the organic stuff. So let's copy these things, copy the operation frame. It's very similar to the things we do when we are working on the alien juicer designed by Philip Stark. So let's go to the solid geometries and choose the toggles. First thing is you need to define the size of the radius and then define the size of the sections. Okay, so let's copy another one. If you take a look of this one, actually this is just a very simple geometries, and it doesn't have much control surface, control point. So just like what we did before, if you want to add on more detail on this one, we need to rebuild this one. So let's type in rebuild. And for the U and V, it means the X and Y in surface world. Not unlike the planar world, we use X and Y. In surface world, we use the U and V to control the number on the direction of the axis. So let's type in maybe in U, let's type in 12, and in V, let's type in less points. Let's just use in 6. And click OK. So as far as you can see, in the vertical part, now we have more iso curve, which means if you press F10 or go to here to select the control points, we will have more points. So now you can start to model, do the things you want. And some industrial designers, they used to using this way to do some super organic model, and it's really hard to do that, but they just know how to control the control curve and to model the things they want. And it's very, very cool, but unfortunately I think for now we don't do that kind of things anymore, because for now we have subdivisions. So If you want to make something more organic stuff or like human face, organic animal, we can using subdivision surface rather than using control point curve. But still, you can use in this way to do that. And if you want to have more counterpoint or more details, for sure, we can rebuild that again. Let's type in more, maybe 18 and 12. So now we have more, and press F10, as far as I can see, we can do more. Okay, so that's the way how we can do E to control the geometry form. And the most interesting thing is this. Although for now it has super complex form, like a super free form, but if we take a look at the geometry, the typology of these two things, actually they are the same. Let's try to do this way. Let's explode this surface and also let's explode this one. Explode and explode. Let's just click this one and click explode. And now it becomes one closed surface. And let's try to do the unroll. Unroll surface. Okay, unfortunately, probably for now it doesn't work. Alright, but anyway, although this one becomes super complicated, but actually this one is still composed by this one. Just has much more control points. So the typologies actually they are same. They have the same typology. Just for this one it has more control points at a much higher degree. And for this one it has lower degree. So that's the major difference. But for in a typology perspective, they still have the same compositions. Alright, so that's the thing we can do with just using control point and reveal to increase the number of the control points and the isocurve so that we can do more detailed stuff. But after the midterm, we can start to using sub-D tools, and that's a new tool in Rhino 7, and it's a tool very similar to Maya, and we can use this one to do something more complex and more precise organic geometries. Alright, so let's take a look of the final one about the blended surface. So for this one, we need to do the things we are going to do is to blend the two surfaces together, and it's a little bit tricky and also a little bit hard to understand. We need to have some mathematical understanding so that we can understand what's the meaning of curvatures. So let's copy this full wireframe to the right side, and let's draw two spheres. Let's select, choosing the sphere, create one, and let's do that again. Press enter. You will repeat the last command which you have done. Okay, so now we have drawn these two spheres, and I want to rotate this one. Don't make these same edge face each other, so I will rotate this one into 180 degree, and for this one as well. Okay, so now the same edge is in this way, and the same edge is in another way. So let's cut this sphere. Let's cut this sphere. Probably I want to cut in this part and connect them together, just to make them become something like a bubble or metaball. So let's using the polyline to draw the cutting curve. If you remember, the things we are going to do is using trim to cut off the sphere. So we have to draw the cutting curve first, and then using trim to cut them. So let's go to the second wireframe. I will copy them to a second wireframe. So now let's go to trim, or using the hotkey Ctrl and T to selecting a cutting object, which means these two lines. They are just like our knives. And once you finish, press enter. And we can choose in the part we don't want to leave. So basically it will be this area. Okay. So now we have two open surfaces right here. So the third thing we are going to do, I will copy them again to using blender surface to connect these two objects. So let's type in blender surface. So we need to, first thing we need to select the first edge and then the second edge. And just like a loft, if you remember, make sure these curve, the direction of the curve, they have the same direction. Don't make them twisted or they have the invert directions. Once you finish, press enter. And unfortunately for now, it seems like it was twisted. So we have to change a little bit. You can change the tangency of the surface and make this one look like a super smooth surface. So for now we can just using vision to adjust. So for example, probably this one looks fine for now. Once you finish, press enter. And now we have merged these two surfaces together. And we can select all of them and press Ctrl J. So instead of finish, let's copy this one again. How can we know if these three surfaces has the same curvature, which means they have the same smoothness? So first thing we need to understand what's the meaning of curvatures. I will draw a curve and so that we can understand. Curvature is the way we use to describe the smoothness of the curve. So if the curvature is higher, which means this one has much large transitions on the curve. And if that one is super low and very close to zero, that curve or that surface is a flattened or linear surface. So let's take a look. I will type in curvatures. And we can choose this one to adjust. So the meaning of curvature actually, as far as you can see, right now if we select this curve, there is a circle which will flow along the curve, and some part it becomes larger and some part it becomes super small. And the meaning of the curvature actually is I will type in. It's like this. Okay, using 1 to divide it by the radius, and the radius will be the radius of the circle on the curve. So I'm going to put it in this way, and I will scale this one. Let's do curvature again. So if the radius is super large, basically, as far as you can see, this arc is very in a super large scale. The section of this area will very close to a linear straight line. So the curvature number of the curvature will very close to infinity. So there will be a linear curve. But if the radius is super small, very small, okay? So the number of the curvature will very close to infinity. So which means this curve is super smooth. And if this one is very close to straight lines, so which means the radius is super huge. So the curvature is close to zero. So the lines, it means the line will be a straight linear line. So that's the meaning of the curvatures. So how can we adjust? No, these three surfaces, they have the same curvature. Actually, it's really hard to know using this way, or it's really hard to calculate because it requires some higher mathematical techniques to do the calculation. So there is a very easy way to see the curvature status. Let's type in zebra. And as far as you can see, when we are using zebra, they will show this kind of zebra pattern on the surface geometries. And you can take a look. If they have a really rough transition between here, basically it means the curvature is not continuous. So for now, because this part is the one we're using for connected, so they don't have the same curvature just like the sphere. But for the sphere itself, they are super smooth, so they are totally fine. And But for the connection part, well, it looks okay, but actually there's a transition between the connection part of and the sphere. So that's the way how we can adjust, how we can see the visual curvatures. But what's the meaning of that one? Why we need to know that? Because when we are working on real product, for example, if your future life you want to become a product designer rather than interaction designer, and you are going to make something like a iPhone maybe iPhone 15 or 20, or maybe some smartphones or iPad or laptop or something, things like that, you need to have a super smooth surface. And if you want to make an industrial model, you need to know the curvature. You need to know how to control the real geometries, how to know the composition and the proportion in a mathematical way. So that's why we're using Rhinosys rather than 3ds Max or Blender and Maya. For that kind of software, they are entertainment industry tools for making games, for making characters, for making animations. But for computer aided design, Rhinosys is a good, very nice tool for us to making product and a real CAD model. But for now, I think as an interaction design department students, usually we only work in digital space rather than real world. So probably Rhino is not that basic tool for you. But for now, Rhino also has subdivision tools, so we still can model inside Rhinosys and export them to things like Maya or Blender. And besides, Rhino has the most powerful curvature tools, these kinds of nerves and surface tools we can use. So I think it's a nice one as a nice start point for you guys to know the 3D modeling. And for the next part, after the midterm, we will start to do the subdivision model. Okay, so that's the things about how we can do in using project, flow along surface, rebuild and sculpting, and finally blend the surface. So the next part we are going to do is to practice a little project so that you can know how we can apply all these kind of command into our model works. Okay, so that's all for today. See you next time.